This section clearly lays out the core challenge. We're using a SCIKITLEARN function, robustscale, to handle data with outliers. The specific dataset contains a single feature, x, with values 1, 2, 3, 4, 5, 100. The goal is to compare how robustscale handles this outlier compared to standardscale. Think about how each method reacts to extreme values like 100. This is the actual dataset we'll be using for this analysis. Notice the outlier, 100. How does this outlier impact the different scaling methods? That's the key question. What would happen if the outlier was removed? This sets the stage for a multiple-choice question. We need to evaluate the truthfulness of several statements regarding the effects of robustscale compared to standardscale. This is a great test of your understanding of how each scaling method handles outliers. Are you ready to tackle this question? Statement A claims that robustscale is less affected by the outlier, 100, than standardscale. This statement highlights the core difference between the two scaling methods. How does the presence of an outlier affect the outcome of these methods? Statement B predicts that the mean of the dataset will be approximately 0 after applying robustscale. This tests your understanding of the effect of robustscale on the central tendency of the data. Will this be perfectly 0, or close to it? Statement C suggests the standard deviation will be approximately 1 after using robustscale. This relates to the variability or spread of the data after scaling. How does robustscale influence the standard deviation? Is the standard deviation approximately 1, or is it something else? Statement D proposes that both scaling methods produce the same result. This tests your overall understanding of the core difference between robustscale and standardscale. Considering the presence of an outlier, are you expecting similar results? This is a crucial section, introducing the main concepts, robustscale and standardscale. It's a good idea to clarify your understanding of these methods before attempting to answer the quiz questions. What are the differences between these scaling techniques? How do they behave differently when outliers are involved? This section introduces the topic of data preprocessing using the popular Python library scikit-learn. Specifically, it highlights the use of robust_scale for handling datasets with outliers. We'll explore how this technique compares to the more common standard scaler. Get ready to learn something new. This line presents the dataset we'll be working with. Notice that the feature x contains a significant outlier, the value 100. How do you think this outlier might affect our analysis? We'll see how different scaling methods handle it. This sets the stage for our quiz question. We're comparing two scikit-learn functions, robust_scale and standard scaler. Both are used for data scaling, but they deal with outliers in different ways. The question is exploring the impact of this difference on the dataset's processed values. Let's see if you can figure out the behavior of each. This is the first possible answer to our quiz. It suggests that the robust_scale method is better at handling the outlier, 100, compared to standard scaler. We'll investigate whether this statement is true later on. This option states that after applying robust_scale, the mean of the dataset will be close to 0. This is a common characteristic of many scaling techniques, but does robust_scale always guarantee it? We'll find out. Similarly to option B, this option predicts that the standard deviation of the data will be around 1 after processing with robust_scale. Is this always the case, or are there situations where this might not hold? This is worth investigating. This last option claims that both scaling methods would give the same results, despite the presence of the outlier. Given how these methods differ, is this likely to be true, or is there a critical distinction? Thinking about how each algorithm works should help answer this. This question asks us to compare how two different scaling methods, robustscale and standardscale, handle a dataset with an outlier. We need to understand which statements accurately reflect the differences in their behavior. Think about how each method deals with outliers and how this influences the resulting data's mean and standard deviation. This statement is correct. Robustscale uses the median and interquartile range, IQR, which are less influenced by extreme values than the mean and standard deviation used by standardscale. The outlier 100 will significantly skew the standardscale results, but will have a much smaller impact on the robustscale results. This statement is incorrect. While robustscale centers the data around the median, the scaling process itself may slightly shift the mean. It won't necessarily be exactly zero. This statement is also incorrect. Similar to the mean, the standard deviation after scaling with robustscale will be close to 1 but not necessarily exactly 1. This statement is incorrect. Because of their different approaches to handling outliers, standardscale and robustscale will produce different results, especially when outliers are present. This statement sets the stage for the quiz problem. We're comparing two scaling methods, robustscale and standardscale, and how they handle outliers in a dataset. The focus is on understanding their behavior, particularly when dealing with extreme values. It's all about how these methods differently manage data that has unusually high or low values. Here's the data we will be working with. The dataset has only one feature, x, containing 6 values, 1, 2, 3, 4, 5, and 100. Notice that 100 is significantly larger than the other values and thus is considered an outlier. This outlier will be crucial in seeing how each scaling method adapts. We'll see the effect of this outlier on the scaling process. This refers to a data preprocessing technique, standardscale, in scikit-learn, a Python library. Standardscale standardizes the data by subtracting the mean, average, and dividing by the standard deviation. The result is data with a mean of 0 and a standard deviation of 1. However, it's very sensitive to outliers. The outlier, 100, significantly influences these calculations. This introduces another method, robustscale, also from scikit-learn. Robustscale uses the median, middle value, and the interquartile range, IQR, instead of the mean and standard deviation. The IQR, which is the difference between the 75th and 25th percentiles, makes it less susceptible to outliers. We are going to investigate how this method is less influenced by those extreme values. This is the first quiz option. It proposes that robustscale, another name for robust scalar, is less affected by the outlier, 100, compared to standardscale. This is the key difference and is indeed correct. This option states that after applying robustscale, the resulting dataset will have a mean close to 0. While robustscale aims for a centered dataset, the final mean might not be exactly 0 after scaling due to the IQR-based scaling method. Similar to option B, this option suggests that robustscale will produce a dataset with a standard deviation near 1. Although this is the goal, the exact value may slightly deviate from 1 because of the scaling using the IQR. This is the last quiz option. It suggests both methods produce the same result. This is false. The methods deal with outliers differently, leading to distinct outcomes, which is the heart of the problem. This section introduces the core topic: preparing data, specifically dealing with unusual values, outliers, to improve the performance of machine learning models. It sets the stage for understanding how different methods, like standard scalar and robust_scale address this challenge. This line presents the specific dataset that will be used to illustrate the differences between data preprocessing techniques. Notice the outlier, the value 100, significantly larger than the others. How this outlier impacts the results is the focus of the quiz. Scikit-learn is a popular Python library for machine learning. This line specifies that the methods used to preprocess the data come from this library, it's the source of the "standard scalar" and "robust_scale" functions. "Standard scalar" is a technique that standardizes data by subtracting the mean and dividing by the standard deviation. This means each data point is transformed to have a mean of 0 and a standard deviation of 1. It's very sensitive to outliers. "Robust scalar" or "robust_scale" is used in the quiz, is a more resilient method. Instead of using the mean and standard deviation, it employs the median and the interquartile range, IQR. The IQR is the difference between the 75th and 25th percentiles, making it less influenced by outliers. This quiz focuses on how to handle data that has some unusual values, also known as outliers. We'll explore two common methods, STANDARDSCALER and ROBUSTSCALE, and compare how they deal with these unusual data points. This is very important in data analysis to get accurate results. Here's our dataset. It's simple, just one feature, X, with 6 values. Notice the outlier, 100, which is much larger than the other values. How will each method handle this outlier? That's the key question of this quiz. The question is asking us to compare the behavior of ROBUSTSCALE with STANDARDSCALER when dealing with outliers. Think about it. STANDARDSCALER uses the mean and standard deviation. Outliers strongly affect these values. ROBUSTSCALE, on the other hand, uses the median and interquartile range, IQR. These are less sensitive to outliers. Option A states that ROBUSTSCALE is less affected by the outlier, 100, than STANDARDSCALER. This is because ROBUSTSCALE uses the median and IQR, which are less susceptible to the influence of extreme values. Option B claims the mean of the dataset after using ROBUSTSCALE will be close to 0. While ROBUSTSCALE centers the data around the median, the scaling process might slightly shift this. It might be close to 0, but not exactly 0. Option C suggests that the standard deviation will be approximately 1 after applying ROBUSTSCALE. This is plausible because ROBUSTSCALE scales the data using the IQR. However, it's not guaranteed to be precisely 1 due to the scaling process. Option D claims that both methods will produce the same results. This is incorrect. They use completely different methods. STANDARDSCALER is sensitive to outliers, while ROBUSTSCALE is designed to resist their impact. Therefore, their outputs will differ significantly.